So I think we should now move on to more general discussion. I might start with a question that I had for Avisa. So I was wondering, with respect to the distinction between origins and causes, is there a particular reason why we shouldn't just think of origins as token causes?
Origins are indeed tokens, but causes can be tokens as well. The difference is that origins are never types, whereas causes can be types. The point is, for this distinction is that I think if we reinterpret several problems that are associated with causation, such as the inference of common cause, in terms of origins, we recognize that we are not really inferring common causes, but common origins. A number of the problems that are associated with causation are actually eliminated. They disappear by dissemblance, by disaggregation of the concept. For example, problems that involve counterfactual theories of causation. So if you just play, I mean, we don't have the time to go into all of that here, but if you play with your mind problem of preemption and that sort of thing, and you just realize we're not really discussing causes, we are discussing information transmissions, actually the problems disappear because they don't hold that well. Information transmission is much less problematic than causation. It's less mysterious and it's narrower. So there's a great philosophical payoff for that. I just think the problem of inference of common causes, I have a paper on that in Studies in History and Philosophy of Science recently. The problem of spurious correlation, the water levels in Venice and the bread prices in England, that sort of thing. If you look at it not as that, we're not looking for correlations that infer common cause, but the common origin, information transmission. Then the question is there anything that could have transmitted information to the water levels in Venice and the bread prices in England? And if that is not the case, then there's no problem. The problem is eliminated. It doesn't arise in the first place. So I think if we look at if we circumscribe the realm of causation and create another realm of information transmission and origin, inferences of origins, actually we eliminate a lot of problems.
Yeah, that actually sounds like something that biologists and philosophers of biology thinking about homology would possibly benefit from, because I don't know if many people here are familiar with the idea of homology. So homology, which is going to feature in my talk tomorrow, is the idea of sameness of characters or traits in biological systems. Could be proteins, could be genes, morphological features, whatever. And yeah, I think this is something that, yeah.
Homologies preserve information from a common origin, whereas homoplasies do not, even though they may share the same features. Homoplasies sometimes can preserve information from the same environment. That is, the development of, but when fur is developing, or when species become naked, as it were, they lose their fur, they preserve information from the same environmental conditions in the past. They don't preserve, of course, information from a common species, but different information channels can be preserved.
Exactly. Well, Adrian, I see you've got a hand raised.
I suppose something that's been going on in the back of my mind over the day so far has been really about what is supposed to sort of unify the sort of notions of origins, right? Because something which is, immediately noticeable and wonderful from about the program is that it's so diverse, right? So we had talks covering so many different things. And I guess what's sort of interesting to think about is what sorts of systematic things seem to come to mind when we start thinking about sort of questions after origins or research programs that are interested in origins of where things come from, and whether there ends up being sort of something we can say. And I guess from Avisa's talk, one thing we might say is origins involve this kind of information-based inferential reasoning. That's one of the things that seems to be going on when we think about origins, but that's also not, and that links really nicely with, like, for instance, the sort of stuff that Craig was saying, right? Where Craig is really talking about problems of information loss and things like that over time. But I wonder whether the things that sort of other people were thinking about quite worked in that same way, right? So I was thinking about particular features of sort of explanation as opposed to features of inference. Of course, those can overlap. And sort of the explanation I might give of an origin is sort of different, of course, from the various inferences I might draw to bring that origin in. And I guess, yeah, I mean, I don't really have anything substantive to say here, rather that I think, one, I've been surprised at how much continuity there has been, given it's such a broad topic. But I'm really interested if anyone else has any ways of either drawing apart or drawing together the different kinds of themes that people have been talking about. Because on the face of it, saying something like, oh, well, I can say something interesting that's true of cosmology, that's also true of historical linguistics, that's going to be substantive, is quite a surprising thing to kind of claim.
Letitia?
Just to respond to that, one of the things that struck me is how much we are still trying to articulate what a scientific explanation is, right? And so, kind of fundamental old Hempelian issue. Like, we know Hempel's useful, but he's incomplete. We agree about that, but I think we're still struggling with figuring out how to go on. And the more you sort of engage the sciences and what scientists are actually doing, I think the trickier that becomes, right? But I think philosophers are still struggling with that, and that's kind of interesting. And that's a thread that I noticed in the talks this morning, is that, sorry, it's morning for me, that, yeah, we're all addressing just that problem of trying to articulate what it is to sort of take robust scientific explanation seriously, what a robust scientific explanation is, whether you're looking at a subtype, which is what we were doing, or larger questions, which I take it is what Visa is interested in.
I think Craig would like to weigh in.
Sure. Kind of continuous with what Adrian said, and I'm curious as well what you think of this, Avi. Is to what extent is it really distinctive of origins or historical imprints? To what extent is it distinctive that it looks for information preserving evidence or traces to infer causes or to infer processes? Yeah, perhaps the commonality is just that's just how science works. Anyway.
Well, I would argue this is how the historical sciences work, because you can see very clearly that there's a time and a place in history when these kind of inferences start, and that is Germany, second half of the 18th century, and from there it moved on to England and so on. And you see at the beginning, these were also the same people. They were just reapplying the same methodology. At that time, they were calling it the philological methodology, because philology was the master science, and they used that in theological texts, and then Ranke used it in historiography and philology, and then the same people also moved into geology, because geology had exactly the same method. And it was all based on, you start with an information theory and you ask what aspects of the present preserve reliably information from the past, from those origins, and then you try to infer back those origins from those traces in the present. And these were the same people. Think about a character like Haeckel, who was working in linguistics, in evolutionary biology, in geology. And it's quite logical, because the division that we have today between disciplines and parts of nature was not viable at the time. The division there was, which methodology are you using? Are you doing historical science, or are you looking for types of things? And then you look for Newton. It would be Newtonian physics, which is not historical and has no space and time. So I think the commonalities here, it's not just that you can see it methodologically, you also see historically, well, which people were doing, which things, and using which methodologies, and with whom they were in touch, and what was actually the scientific community at the time. And you will see that it was not based on this kind of obsolete sense of realms of nature, and that's something that the neo-Kantians later in the 19th century captured very quickly, that the distinction is not anymore between human sciences and non-human sciences. It's an obsolete distinction that we still have today, but it would be historical sciences or cultural sciences or spiritual, Geisteswissenschaften, spiritual sciences and something else. And today, in using much more sophisticated tools than Adrian and people like Carol Cleland, Dirk Turner, Elliot Sober, but we're confronting those same age-old questions, but we're trying to use our contemporary tools that were not available for the neo-Kantians. I think if Windelband was with us today, he would have thought like me, even without the beard.
Yeah, I just wonder, so if you look at, take experiments being conducted at the LHC, to what extent are they not also taking the results of scattering experiments and searching for signal in noise and trying to reconstruct what happened? That's kind of what's
right. But the interest when you look at particle accelerators, what they're interested in is not in the particle that appeared at the moment t at a particular space. They are interested in the particle as a type. And if the experiment doesn't go well, okay, that's not a problem. They'll run the experiment again. But with historical sciences, we cannot rerun the experiments. So even if we could run them, they wouldn't have the same significance. That is, we are interested in the invention of language at a particular space and a particular time that led to the present. And when information was not preserved, there are just a hell of extremely interesting questions that we cannot possibly answer. What was the first language really like? What was the religion of the cave dwellers? Did Neanderthals have a language? Were Neanderthal capable of symbolic representation? A lot of extremely interesting questions that if information decayed on the way from the past to the present, we will never know anything about that. Think about it in a simple, suppose that somebody who's very interested in our conference today cannot be with us. And tomorrow they want to reconstruct what happened today. What they would do is they would get a list of people who are available here on Zoom, 30-something people, and then they would interview them. They would get slightly different accounts, and then they would infer from the commonalities in the information preserved and so on, what happened today. And they would probably be able to do a fairly good job of it. But suppose that 100 years from now, somebody is trying to do that. Well, almost all this information will decay by then. We will all be dead. Unless somebody took notes, there would be nothing else. There would be at most a list of participants. And then the historian 100 years from now, if they have nothing better to do but try to understand what we were doing, they would look at the kind of publication we produced around this time and correlate that with the abstracts and get some kind of picture. But of course, they would know much less. And then, run that 1,000 years from now, 2,000 years from now, and so on. And you'll get to this lovely, there was an inference of somebody, I think, in the 17th or 18th century, when would the second coming of Jesus be? And they concluded when the information that is transmitted by the New Testament totally decays, God will have no other choice because all the information will be gone. There will be no basis for faith. And then there will have to be the second coming. And a part of this, this funny way of theological thinking, the assumption is information decays progressively. And in the same way that as time passes by, we more and more of the galaxies are running away from us, and we will not get information from them. And that's the kind of picture of the universe that I'm thinking of.
I think I might pick up on Craig's point and say something in support of it. So something which Sabine Leonelli argued recently, and I've played with in a few places, which I think really does make all evidential reasoning historical, just involves pointing out that evidential reasoning is not on the basis of experiments, it's on the basis of data. It's not on the basis, like when I'm making an evidential claim, what I'm doing is I'm grabbing data and I'm using that data in order to, evidence some hypothesis or whatever. And anytime I do that, what the genealogy of the data matters, how the data was produced, where it was, like the conditions, how it's been stored, all of those journeys that the data has gone on. And if that sort of view's right, then it seems like any instance of evidential reasoning, in some sense at least, involves an historical inference, because after all, you're at least making some kind of commitment to the data being, produced in the right way, or something like this. So I think there's something really interesting about that perspective, where you start taking what Leonelli calls data time sort of seriously, right? So Avisa and us and Craig, we're already talking about what she calls phenomena time, right? It's the temporal scope over which the thing we're trying to study has changed. The critter turns into a fossil. But there's also data time. There's also the time from when the data is produced and recorded and then put into various tables and put into various bases and then used in various ways. And it, of course, distorts and changes and breaks. And so you find the same, I don't know if it's the same, right? I don't know if it's as formal as Avisa was putting it when we're talking about that very specific common cause reasoning that folks are using from the 19th century onwards. I don't know if it looks exactly like that, but nonetheless, it's an inference to the past that's required for that evidential reasoning. So I guess I'm inclined to think that, at least in that sense, the sort of point that Craig was making, I think actually holds quite generally, which I don't know is interesting.
I think that the danger would be of deflation by overinflation. If everything is historical, then nothing is historical. I think of it sometimes as the difference between the historical and the theoretical sciences, the difference between French and Australian wines. French wines are historical. They tell you exactly which year, which bouquet, which area. It's all tokens. Australian wines became popular by producing types of wine. You don't know which year, you don't know which area exactly. It's a Shiraz and that's it, and it's good. So the theoretical sciences, they're not interested in when did you make this experiment? Where was it? They're just interested in the type of things, and if it goes wrong, it goes wrong. Whereas the historical sciences, it's always, there's a token there, there's the space and time when it happened. The French Revolution is interesting, not because it was a revolution, but because it happened when it happened, at the time that it happened. Whereas when sociologists or political scientists talk about the revolution, they're not interested in the French Revolution. They're interested in the Shiraz, as it were. They're interested in the type of event, in a revolution.
Yeah, I suppose I buy that. I sort of buy that. I think that there are folks who care more about particulars and folks who care more about regularities. And of course, there are folks who are sitting in between, right? I suppose that the worry that I often have from the perspective as philosophers of science is these really big categories like the historical sciences, the theoretical sciences, the experimental sciences. It often strikes me that there's just so much variation within those sorts of sciences. And in fact, often more variation, as it were, within each than there are between them, that I start getting really worried that we're not getting as much sort of, if you want, explanatory traction as we would want, because they're so sort of abstract. I do think that your work and also Elliot Sober's work are quite nice examples of how you can actually get some really interesting juice out of thinking in these very sort of abstract ways. But I'm still left kind of, so I guess my response to the, oh no, you just drew everything too broad and now nothing means anything, is I'm like, yeah, but those categories weren't great in the first place. We should be looking for categories that are much more fine-grained and actually will often cross-cut different sciences, right? But yeah.
Okay, we have gone over the official end of the session. I'm just gonna say one last thing. I imagine if we come up with new categories, they're going to have their own shortcomings and they're going to be useful for different things. Who knows? Maybe new departments will be based on those categories.